Rapid 2023, there are a lot of different technologies for making things with additive. Filament-based tech is one of them. I'm with Luis Rodrigues. He's application engineer with Ultimaker. Luis, we're standing next to a filament-based machine. Before you tell me about the machine, tell me about the principle. How does filament work?
So at the basic level, you can think of it as a computer-controlled glue gun. We're extruding a polymer layer by layer, much like you would see in a CAT scan. Anything in 3D can be represented in a 2D slice. We reassemble those slices into the 3D image that you see. We have the benefit of a million polymers to choose from, and so we use that to sort of solve people's problems.
Now, in this particular machine, I see that you have sort of a cassette and a bank, and the raw material comes as literally a wound sort of resin filament on spools. That's how it's shipped?
Yes, exactly. All these material companies will extrude this filament onto a spool, and then we can, it's a set, formula for the industry. We can insert it into the machine and then, add things like software to detect what's there. But we get the benefits of those different properties from all these different polymers.
And what sorts of polymers can you offer this? Commodity polymers, engineering resins, composites?
So because we're an open system, it's all of it. We can do everything up until, say, Ultim and some of those special high temp ones. So we're talking about PC, PCABS, but also PLAs and tough PLAs and everything in between, from carbon fibers to even some of the metal filaments that we see.
Now, you mentioned it's an open system. Is a proprietary technology? Could customers have to buy the resin from you, or can they go to outside suppliers?
No, so we manufacture about 10 of our own name brand, and the only proprietary part is we have an RFID sort of chip in them just to tell the machine what's in it and help set it up for you. And then we have a marketplace where we've got 60 or 70 of these material manufacturers, and they have certified the material. So they've used our software and they provide a profile for you. Beyond that, anything else that exists in the world you can use. You're just responsible for setting up the projects using their manufacturing recommendations. So it's sort of can grow with you as you become an expert in the polymers.
Now, filament-based systems normally are thought of as polymer. They're resin-based things, but metals are a possibility here, correct?
Right. So in one instance, we're using ultrafused filament from BASF. It's the same feedstock that's in metal injection molded. They have a polymer and a wax binder to get into the filament form. We print it as a green part, pre-warped, it's scaled up, and then they send it off to a facility that debinds and sinters the part, and you get back a near net shape in either 17.4 pH or 316 stainless. So that's the beauty of a system like this, is from day 1, 2, and 3, I can switch from standard polymers, engineering, to even a specialty like metals.
Now, the machine we're standing next to now, I understand you've just announced this. Tell me about it.
So it's the S7, it's the flagship product for Ultimaker. It combines a lot of what we loved about what we called the S5 Pro Bundle, and now we've included a lot of those things in it. So we've got air management to keep the build volume stable, but also make sure it can work in an office environment. And then some nice productivity features with a flexible bed, so we don't have to worry about bed adhesion. And then it still works with this material station that we referenced earlier. So it's all in all, you get this great, what we call a Pro Bundle, so you can do all those things that I mentioned.
Now, filament-based systems for a long time have been thought of as strictly prototyping systems. I can't make production parts on that. Is that true?
Well, so prototyping is a very valid solution for those, but because of the material selection that we have now, we've got customers that go all the way to functional prototypes to even end-use products because of the strong filament specifications that people provide. So it's kind of up to you and your industry, but certainly prototyping is a large portion, but you can't pretend that it can't do functional or end-use parts.
Which industries are the biggest users of this particular technology?
So we see a lot of use in, honestly, any industry that has a factory. Food and beverage, automotive, any of those factories cannot stop moving, right? It's a manufacturing minute. It costs thousands of dollars a minute. Even the most successful company needs to wait for something to be shipped to them. So what they found over time is they might print the spare part, and then over time they found out this printed part works just as fine or better. What I like to tell people is that you've got an opportunity to personalize and customize these printed applications. You can more often improve the spare part by redesigning it a little bit.
Filament-based technology for production parts and prototypes in polymers and metals at Ultimaker. At Rapid TCT 2023, the air was electric. The excitement about manufacturing in America is palpable. New technologies, new ways of implementing additive manufacturing, not just for prototyping, but as a true production process, were all over this show floor. The future looks very bright for manufacturing in America based on what we have seen here. Thanks for joining us on the show floor. See you next time. Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today.